Okay, so let's make a context-free grammar for this language, which is the set of all strings of the form a to the n, b to the n, which means that we have an equal number of a's and b's. Whenever we think about a context-free grammar problem, we need to think of two things, the base case and the recursive case. So here, the base case is when n is equal to 0, the smallest possible n for which a string like this exists. Well, that's just the empty string. So if we start making our grammar, we need a variable, and we need to generate the empty string, obviously, because that is the base case. But we now need to think about the recursive case. Well, the recursive case says we have an equal number of a's and b's, and all the a's come before all of the b's. So therefore, if we have some string that is not the empty string, that means that there is an a in there somewhere, and therefore it needs to be in the first half. Consequently, there must be a b in the second half. Well, if we generate an a at the beginning and a b at the end, the thing in the middle, since we're popping off, in some sense, one a at the beginning, one b at the end, therefore the thing in the middle must be another string of the form a to now n minus 1 and b to the n minus 1, same form. So therefore, if s, by assumption, makes all the strings of this form, therefore, we need to recursively call s in the middle here. And so we make the rule, s goes to a, s, b. So we make an a at the beginning, make a b at the end. So let's do an example. If we have n is equal to 10, then what we can do to generate that string is to apply this rule 10 times, making 10 a's at the beginning, 10 b's at the end, and then finally conclude by changing that one s into the empty string. And so therefore, this is a quick and easy grammar for the set of all strings of the form a to the n, b to the n.